For months, Tesla said almost nothing, and then this happened. A fully dedicated production line for the Model 2 Senior Edition is now operational, and it's nothing like a traditional EV factory. Built from scratch, finished in record time, and engineered around efficiency at a level rarely seen in affordable cars. The big question is why Tesla went this far for one model, and what does it mean for affordable EVs in 2026? So here's the twist nobody saw coming. Tesla didn't just add a few machines to an existing factory. They built an entire production line from scratch, fully dedicated to the Model 2 Senior Edition. That's huge because most affordable EVs just get shoved onto older assembly lines where the layout, equipment, and workflow weren't designed for them. This isn't just faster production. It's a completely reimagined approach that makes every step leaner, tighter, and more precise. Why does that matter right now? Well, building a line this way lets Tesla reduce part movement, cut down assembly steps, and keep everything in sync. Every station is designed to feed into the next, with minimal human effort. Instead of a long, clunky conveyor where cars crawl along while workers and robots jump around, this line is modular and compact. Parts move exactly where they need to be. Machines and robots operate in perfect rhythm. And the best part? If one module needs attention or calibration, the rest of the line keeps moving. That's something legacy EV factory downtime often slows the whole system. Think about it. By dedicating this line just to the Senior Edition, Tesla can make design choices they couldn't on a multi-model line. Ergonomic interior modules, narrow battery integration stations, and specialized cabin assembly cells all fit neatly into the workflow. No compromises, no retrofitting. It's all purpose-built. Experts in manufacturing efficiency say this level of modular integration is rare, especially for sub-$30,000 EVs. Most competitors still rely on long shared lines that were designed decades ago. This gives Tesla a real advantage if they want to scale quickly while keeping quality consistent. And there's another subtle benefit. The line is designed for speed and flexibility. Even though it's optimized for the Senior Edition, it can adapt to small updates or different sub-assemblies without major shutdowns. Tesla is essentially future-proofing the workflow while keeping output tight and consistent. That combination of focus, precision, and adaptability is exactly what sets this line apart. So, a dedicated line isn't just about speed. It's about control, efficiency, and quality from start to finish. It's a sign Tesla is serious about getting this model right for its audience, not just cranking out numbers. But building the line was only the start. Next, we'll break down how Tesla achieved record-breaking speed on this line and what makes the construction process so different from anything else in the EV world. Tesla didn't just build a dedicated line. They built it fast. Faster than almost anything in EV history. From the moment the first machines arrived to when the line went into calibration, it took roughly 82 days. That's just under 3 months to get a fully functional production system ready for a brand new car. For a sub-$30,000 EV, that's almost unheard of. Most competitors take double or even triple that time just to get equipment in place, let alone running smoothly. Why does speed matter so much? The faster a line is operational, the sooner Tesla can produce cars and respond to real-world demand. Every day saved in setup translates to hundreds of extra units a year without compromising quality. And this isn't a simple conveyor line. It's a hybrid linear cellular system. That means multiple subsystems, from battery assembly to interior modules, had to be installed, synced, and tested simultaneously. Normally, automakers stagger installation over months, but Tesla compressed everything into an intense, high-precision window. Experts in automotive manufacturing point out that building a line quickly without sacrificing accuracy is extremely rare. Modular stations had to be aligned, robotic lifts calibrated, and gigacasting presses installed and stabilized, all in just over 80 days. By comparison, legacy EV lines often spend 6 months or more just on calibration and dry runs. Tesla's pace signals not only efficiency, but also a high degree of confidence in their engineering and planning. And there's a subtle but important effect here. Speed doesn't just save time, it also minimizes disruptions. The shorter the installation period, the lower the risk of errors creeping in from multiple contractors, delayed shipments, or misaligned systems. This level of precision early in construction sets the stage for smoother ongoing production, fewer bottlenecks, and a more predictable output rate. So while the headline number is impressive, 82 days from equipment delivery to calibration, the real story is how carefully Tesla orchestrated every piece of the line to work in perfect sync. It wasn't just fast, it was fast and smart, making the production line ready for a high-volume rollout from day one. Next, we'll take a closer look at the physical layout of the line itself, how Tesla's design choices, modular stations, and workflow strategies all come together to make this one of the most efficient EV production systems in history. When you step inside Tesla's Model 2 Senior Edition line, even just in photos, it's immediately clear this isn't your typical factory. The layout is completely different from a standard conveyor system. Instead of one long line where cars inch along while parts and workers weave around, Tesla built a hybrid, linear cellular design. Each major process, battery installation, interior assembly, and body casting, has its own mini station feeding directly into the main line. Everything flows together, but each module can operate independently. Why does this matter? Because this modular setup means the line can run more efficiently and with fewer interruptions. If one station needs maintenance or calibration, the rest of the line can keep moving without causing a full shutdown. Compare that to traditional EV lines, where one problem often halts the whole production flow. For a car designed specifically for seniors, Tesla can maintain high consistency and quality, which is critical when comfort and ergonomics are the priority. Experts in automotive production say this type of layout is unusual for a compact, affordable EV. Most competitors still rely on long linear lines that try to handle multiple vehicle models at once. That often introduces bottlenecks and slows down the overall output. Tesla's approach compresses travel distances for both parts and vehicles, reducing wasted time. A shorter line, paired with precision microstations, means every movement of a robot arm, a battery, or a cabin module is intentional. Another clever part of the design is how parallel stations feed into the main conveyor. Battery packs, chassis components, and interior modules arrive exactly when needed, which cuts down on storage, shuffling, and extra handling. That kind of timing and coordination is usually seen in aerospace or high-end electronics, not in a $30,000 EV. By bringing it here, Tesla is squeezing efficiency out of every square meter of floor space. So the physical architecture isn't just about looking futuristic. It directly impacts speed, reliability, and quality. Every decision in the layout was designed to keep the line running smoothly while maintaining the standards expected for a car aimed at older drivers. Next, we'll dive into the heart of the line itself, the gigacasting presses, and see exactly how Tesla replaced hundreds of individual parts with just 2 massive castings, saving time, cost, and complexity. Right at the center of Tesla's Model 2 Senior Edition line are the gigantic casting presses, and they're doing something most factories still dream about. Instead of welding together hundreds of small stamped parts, Tesla uses just 2 massive castings, one for the front, one for the rear. That means roughly 270 individual pieces are now replaced by just these 2 components. It's efficient in steel and aluminum form, cutting complexity and saving a huge amount of time on every single car. Why does this matter? Well, traditional assembly lines spend days welding, trimming, and aligning hundreds of pieces for each chassis. Every extra part introduces risk, misalignments, defects, or extra labor. By collapsing the structure into 2 main castings, Tesla eliminates dozens of steps before the car even reaches the main line. It also reduces human intervention and the chance for errors, something that's especially important when you want every car to meet high standards from day one. And the presses themselves are impressive. Each one weighs 6,500 tons and sits on reinforced concrete slabs with vibration-dampening plates. That setup keeps the castings perfectly stable during rapid cycles, which is key when you're producing tens of thousands of cars a year. Engineers say that stabilizing machinery of this size, while maintaining speed and precision, is not easy, especially for a line that's been built from scratch in such a short window. Tesla didn't just stop at size, they also tweaked the alloy used in these castings. By reducing redundant ribbing and slightly changing the composition, the material flows smoother, the castings are less brittle, and defect rates drop. That's a small detail with a big impact. It means fewer rejected parts and less downtime during production, which keeps the line running efficiently and reliably. Experts note that while gigacasting isn't new for Tesla, applying it to a sub-$30,000 EV with this level of precision is unusual. Most competitors still rely on traditional welding and stamping, which takes longer and can create inconsistencies across each vehicle. Tesla's approach here compresses the process while maintaining the structural integrity that buyers expect. So these presses aren't just big machines, they're the heartbeat of the production line, reducing steps, saving time, and setting up the rest of the assembly to run smoothly. Next, we'll look at how Tesla's precision machining corridor takes over from the castings and gets the car ready for battery and interior integration, trimming seconds off every unit along the way. Once the gigacastings are in place, Tesla doesn't just let the car sit. It moves straight into the precision machining corridor, and this is where the real magic of efficiency shows up. The corridor is only 31 meters long compared to competitors like Volkswagen's ID.3, which uses a 52-meter setup. That shorter distance might not sound like much, but It cuts about 14 seconds per car, and over tens of thousands of units that adds up to hundreds of hours saved every year. Here's why this matters. In traditional factories, after welding or casting, cars often have to travel long distances to reach drilling, trimming, and mounting stations. That travel time slows down the line, adds complexity, and increases the chance for misalignment. Tesla's setup keeps everything compact. 8 high-precision fan units handle drilling, trimming, and finalizing mounting points in a tight, controlled space. By keeping tools and stations close together, robots can work faster, and humans don't have to move around as much. Experts in manufacturing efficiency point out that reducing even small cycle times is crucial for volume production. It's not just about raw speed, it's about consistency. Shorter travel distances mean fewer chances for mistakes, less wear on equipment, and smoother integration with the next stages like battery and interior installation. For a car like the Senior Edition, where comfort and fit are key, that precision pays off in better alignment and smoother finishes. And Tesla went further. The corridor is designed to match the cadence of the line, meaning the machines operate in sync with the incoming chassis. This tight coordination trims seconds off every unit, but it also allows the line to run more continuously. If one station finishes early, it waits just long enough to let the next step catch up. No bottlenecks, no wasted energy, no delays. It's a small but critical detail that adds up to significant efficiency gains. So the machining corridor isn't just another step. It's where the Giga castings become ready for the real heart of the car, the battery and the cabin. By combining compact design with high-precision robotics, Tesla ensures the Model 2 Senior Edition is built faster, cleaner, and more consistently than most sub-$30,000 EVs on the market. Next, we'll see how Tesla integrates the battery packs directly into the frame and why their approach could save minutes per car while boosting long-term reliability. One of the most impressive parts of Tesla's Model 2 Senior Edition line is how the battery packs are integrated directly into the car frame. Instead of adding batteries as a separate, time-consuming step, Tesla's line lifts the battery into the casted structure using a synchronized triple arm lift. Each pack has to fit within a plus or minus 0.7 millimeters tolerance, which is incredibly precise for a vehicle at this price point. That means fewer adjustments, less shimming, and a faster assembly overall. Why does this matter? Traditional EV lines often require extra handling to secure the battery, which adds minutes to every car. Multiply that by tens of thousands of units, and it becomes a big drain on efficiency. By integrating the battery at this stage, Tesla cuts roughly 5.2 minutes per car off assembly time, and those minutes add up to thousands of labor hours saved annually. It's a simple change with a huge ripple effect on production capacity and cost. Experts point out that this method also improves long-term reliability. Bolting the battery directly into the casted frame reduces stress on mounting points, ensures perfect alignment, and lowers the chance of vibration-related wear over the years. For a car aimed at older drivers, who prioritize consistency and durability, that precision is a real selling point. Tesla's approach here is unusual in this segment. Most sub-$30,000 EVs still rely on traditional battery installation methods, which take longer and require more manual intervention. By building it directly into the structure, Tesla isn't just saving time, they're raising the quality bar for this category. So battery integration isn't just a single step in the process, it's a core efficiency driver that powers the entire production line. It's faster, cleaner, and smarter, giving the Model 2 Senior Edition a head start even before it leaves the factory. Next, we'll explore the interior assembly and the ergonomic cabin modules, and see how Tesla designed this part of the line specifically for older drivers, keeping comfort and consistency at the forefront. After the battery is perfectly slotted into the frame, the Tesla Model 2 Senior Edition moves into the interior module assembly, and this is where the line really shows its clever design. Tesla isn't assembling each seat, hinge, and glove box separately. Instead, they've created pre-assembled ergonomic cabin modules that are built as a single block and then robotically indexed into the car in one smooth motion. That means fewer steps, less chance for misalignment, and a consistent fit every time. Why does this matter? Older drivers notice the little things: low-effort door hinges, wider-angle seat rails, soft close glove boxes, and steering that feels lighter but precise. Traditional assembly lines often install these items one by one, which increases labor time and opens the door for small but noticeable imperfections. By combining all comfort elements into a single module, Tesla speeds up assembly while keeping quality high. The module sits just 18 meters from the main conveyor, so robots can move it into position almost instantly. That's shorter than most factory layouts, where cabins travel much longer distances before installation. Every second shaved off here adds up across tens of thousands of cars, and it keeps the line moving without unnecessary stops. Experts in industrial design point out that integrating comfort and precision like this is rare, especially for an EV under $30,000. Most competitors still treat ergonomic features as afterthoughts. Tesla's approach ensures that every Senior Edition car delivers consistent comfort without slowing down production. It also pairs perfectly with the modular nature of the entire line. If one module needs recalibration or adjustment, it can be isolated without halting the rest of the line. That means fewer delays, smoother throughput, and a factory that can respond quickly if something isn't perfect. Next, we'll take a closer look at how Tesla's modular line layout keeps everything running continuously and why this could allow the Model 2 Senior Edition to hit production targets faster than anyone expected. Tesla didn't just design a fast line, they made it flexible. The Model 2 Senior Edition line isn't one long, continuous conveyor like most factories. Instead, it's broken into 5 independent modules, each with its own mini-buffer and error isolation system. That means if one module hits a snag, whether it's the casting press, the interior module, or battery integration, the rest of the line keeps moving. Why does this matter? In traditional setups, a single issue can shut down the entire production line, costing hours or even days in lost output. Tesla's modular approach allows the factory to isolate problems, fix them quickly, and continue production at partial capacity. Over time, that adds up to a huge increase in overall efficiency and fewer delays for deliveries. Each module is designed to operate semi-independently. For example, while the casting section recalibrates, the interior assembly and battery integration modules can still process cars already in progress. This separation reduces downtime dramatically compared to older EV production lines, where a single hiccup can create a chain reaction of delays. Experts in manufacturing efficiency point out that this kind of modular design is rare in budget EV production. Most sub-$30,000 cars rely on traditional linear layouts, which are easier to set up but far less resilient. Tesla's approach allows them to scale faster, adapt quickly to supply fluctuations, and maintain a high-quality output even under pressure. So, Tesla's modular design isn't just about speed, it's about keeping the line running no matter what. It's a smart mix of efficiency, adaptability, and quality control that helps explain how they can push output faster than anyone expected. Next, we'll dive into the battery strategy behind the Senior Edition, including LFP, sodium-ion, and even the experimental aluminum-ion modules, and why this could reshape EV choices for older drivers. The Tesla Model 2 Senior Edition line isn't just fast and clever, it's built to produce big numbers. Early estimates suggest a sustained output of 92,000 to 110,000 units per year, with a theoretical maximum approaching 128,000 cars once a second shift is added. That's remarkable for a sub-$30,000 EV, especially one designed specifically for older drivers who value comfort and reliability over sporty performance. Why does this matter? These numbers hint that Tesla isn't just testing the waters. They're aiming to make the Senior Edition a serious player in the EV market. Competitors in the same price range, like BYD's Dolphin or canceled GM projects, don't have production lines this integrated or this fast. This kind of output capacity signals confidence that the car will not only meet demand, but also maintain high quality across every unit. The modular layout, precision machining, gigacasting, and pre-assembled interior modules all feed into this. Each innovation isn't just for efficiency, it's about keeping the line running consistently at high volume. That combination of speed and precision is rare in affordable EV production, and it shows how Tesla is redefining what's possible at this price point. Another signal comes from the battery integration and upcoming chemistries. Tesla plans to start with LFP packs and gradually expand to sodium-ion and aluminum-ion modules. By having a line that can handle multiple setups and maintain output, Tesla can adapt to new technologies quickly without halting production, giving the Senior Edition a potential edge in both reliability and innovation. So, what does this all tell us? Tesla's Model 2 Senior Edition line isn't just about building cars. It's about building a system that can scale, adapt, and maintain high quality for a demographic that's often overlooked in the EV space. Every design choice, from modular architecture to ergonomic interiors, feeds into a production strategy that's as precise as it is ambitious. The story of this line is far from over. With production already humming and early deliveries on the horizon, we're seeing a new approach to EV manufacturing that could influence not just Tesla, but the entire sub-$30,000 EV market. The question now is, can Tesla hit its late 2026 delivery targets and keep this momentum? And if they do, how will it reshape expectations for affordable, senior-focused electric cars? One thing is certain, this line is more than just machinery. It's a glimpse into Tesla's future strategy, and it may be a sign of bigger moves coming in EV production that nobody is fully expecting.